So as we go into the structure of computer networks, our networks have some characteristics, and these characteristics are called as wired and wireless characteristics. So the networks will have either a wired network or a wireless network. Wired network will be found in homes, schools, businesses and government facilities, and wireless networks will be found in homes, schools and businesses. Along with that, it will be found in Wi-Fi hotspots like coffee shops, business, airports, hotels and libraries. So in a wireless network, the devices are connected through a wireless through radio waves, and in a wired network the devices are connected to a physical cables. So next, coming to the going towards into the networks, these devices are connected in some fashion. Now the geometrical structure in which these devices are connected is called as topologies. So the devices may be connected in any topology, any structure, any fashion depending upon the network administrator. But out of all this, we will be discussing some basic structures which we will be using in our daily life. Once out of that, certain applications certain topologies are star networks, a bus network and a mesh network. Now what is the star network? Means here all the devices are connected to a central device, and the central device is called as hub. This is a low intelligent device, and whatever information is given to this device, that device will give the information to all the devices connected to it. So security issues are more in these devices, and troubleshooting of this network will be very easy, because if any connection between the hub and the device is not working, only communication to that particular device cannot be done, but remaining all other devices communicate with each other. These are the advantage of this network. And next one is a bus network. This we usually find in our laboratories, where there is single line of cable, Ethernet cable is there, and to that many other devices are connected. Here, wherever the cable is disrupted, let us suppose look at the cursor on the board. So whenever if there is a disruption here in this cable, the communication will be stopped ahead of this disruption. Why? Because we can't communicate with all other devices after that break in the connection. So this requires a less amount of cables, cost is less, and if working, it will be a very good one. Then again, next topology is a mesh topology. Here each device is connected to all the devices. So you can see that if let us take this devices A, B, C and D. Device A is connected to B, C and D, like the device B is connected to A, C and D, and device C is connected to A, B and D, and device D is connected to A, B and C. All devices are interconnected to each other, and here troubleshooting is little bit difficult because more number of cables will be there. But this type of structures we use in local area networks or WAN topologies, where we want to communicate with different networks. Next, so we have we have some applications of our computer networks. So in this application of computer networks, we have some network architectures. What do you mean by an architecture? An architecture is a way in which networks are designed to communicate with each other, in which your devices are placed in such a way that they can communicate with each other. In this we have a client server network. So this is one structure in which we take one particular device or a system as a server, and the remaining all other devices working as a client, and it is having its own advantages. So client, what is a client here? Means a computer or other device on the network that requests or utilizes the network resources. So what are the network resources here? Network resources like here is it can use the bandwidth. So so this is a server in which we store some information. What information we will store? Like some files. Let us suppose that this server is a server of some organization, and the files which are used by the office people, they will be stored here. all the information is stored in this in this server. Some client wants to know what happened earlier, then this client can have a request to this server asking to open that, asking to give a particular file to it. Then the server will respond to this client and it will give the particular file to this client, so that this client can go further and complete the work. Now server, what is a server? Computer dedicated to processing client requests. So this server means it is a dedicated system which is going to process all these clients request. So in this client server structure, client is going to request for the information. Server will never request for the information to the clients. This is one important point we have to remember. So this is called as a client server architecture. So this is one structure of architecture of networks, where we make one device as a head and we store all the information in that, and remaining all devices will be like clients, and the other clients these client devices can request for the information to the server and get the information from the server. So in the next architecture we have peer-to-peer, that is P2P networks. Peer-to-peer means single device connected to other device. So here all computers are at the same level. So whatever devices here are there, they are connected to the same level. Now this is the example like a star network. Here you have a hub over here, and this device is device A, and let us consider this as device B. A is connected to a hub and B is connected to hub, and we can communicate between A to B. So this is called as a peer-to-peer network. So where two devices are interconnected with each other. This is a point-to-point network. And we also have a internet. Internet is also a peer-to-peer network, because internet also each device is connected to other device to which it wants to communicate, and where information can be transferred from one device to other device. Next, so these networks are of different sizes as the physical area they have been covering the physical area. So the first small network is a personal area network. It's called as a PAN. Connects an individual personal devices that are located close together, like our internet in our home. We have a router, and all our mobile phones, our laptops, our television, everything is connected to that router. Okay, next is a local area network. Connects devices located in a small geographical area. So let us suppose that you are living in a particular area in your hometown, and in that particular area, let us be there are 4 or 5 vendors who are supporting for the internet, like Airtel, like VI, like XL Broadband or somebody, and you want to connect you want to take internet from the internet service provider from the XL Broadband. So this XL Broadband will connect this XL Broadband people will have a network with all the other people in that area, and this particular geographical area in which how many customers have taken the service of XL Broadband. If we figure out that and we draw a picture of that, then that will become a local area network called as LAN network. Then is a metropolitan area network. It serves like a metropolitan area. That is a wider area which is larger than your local area network. And then one next coming network is called as a wide area network. It's a large geographical area, like our complete state, our complete country, like that. Bigger geographical areas are there in which we are going to communicate with the devices. The wide area network is having a different protocols, and the local area networks are having different protocols, and we should be able to communicate between these two different structures. Next, a quick quiz. So whoever are watching this video, please you can answer these quizzes so that you can have a basic idea of what you have learned. Right. So these are the self-assessment questions we have given. So you can answer these questions, and you can learn you can understand how much of knowledge you have gained. So these are the terminal questions, and these are the reference books. Thank you.